Okay, so total revision about assertion. Okay, so first thing, how many types of assertions are there? Two types of assertion. One is concurrent immediate assertion. Another is concurrent assertion. Immediate assertion means it just check the condition immediately, like in same clock cycle. If I go to concurrent assertion, it checks the condition over a range of clock periods. Okay, if I'm taking some example, then here I can simply write assert at the rate passage of clock let some condition if start equal to 1, then assert signal A or signal B. So here what will happen, it will check, okay, whenever the start is equal to 1, it will check whether A equal to 1 or B equal to 1, just that one only. Okay, it is not going to check like over a range of clock periods. Whenever passage of clock, only at that time it is going to check it. Now coming to concurrent assertion, it checks over a range of the clock period. Okay, so and in concurrent assertion you have to use like assert property. If you are using assert property, this statement, that is means it is a concurrent assertion. Okay, how you can differentiate between immediate and concurrent assertion? By this assert property. So I can write property, let assert property P1. Here I can define a property P1 at the rate passage of clock, let if start equal to 1. Okay, then hashes after hashes 1 clock cycle, some signal grant should be 1, then after 2 clock cycle grant request should be 0. So here it is going to check over a period of clock cycle. Whenever start is equal to 1, after 1 clock cycle it is going to check whether grant is equal to 1 or not, then after 2 clock cycle it is going to check whether request is equal to 0 or not. So end property, remember here whatever the passage of clock you have to give here. Here you cannot write like assert at the rate passage of clock property P1. It will give you error. You should not write like this. Okay. So now this hashes 1 means after 1 clock cycle. So here this is range of, sorry, this is simple delay. So you can give a range of delay also. How can you give range of delay? And here I am writing 3 to 5. So here what will happen? Start is equal to 1. Then it will check after 3 clock cycle or after 4 clock cycle or after 5 clock cycle whether grant equal to 1 or not. If grant is equal to 1, then assertion passed. So it is going to check over a range. It can be 3 after 3 clock cycle, it can be after 4 clock cycle, it can be after 5 clock cycle. So you can either give simple delay or you can give range of delay. Okay. So this is concurrent assertion. So concurrent assertion, how the, like they may ask you the question, what are the building blocks of assertion? So we have property. This property, they consist of sequence, and this sequence they consist of Boolean expression. So let here this is a simple condition, so I can write inside property directly. Let you have so many conditions, so you can write so many sequences and you can use that sequence inside a property. How? Let example, same things only I'm writing. Sequence S1 So in sequence you can give @passage of clock, or in the property also you can give. Okay, here I am writing simple these things. And sequence. Then sequence S2. Here also let something like when start is equal to 0. Start is equal to 0. Then then after let 1 to 3 clock cycle, grant should be 1, then request should be 1. This is another signal I am writing. Okay, start 1, grant 1. So this is another condition and sequence. Now in the property, P1. So here you can call @passage of clock, sequence S1. After hashes 1, or I can write hashes 0 clock cycle, sequence S2. Then end property. That means whenever sequence 1 is passed, okay, sequence 1, after sequence 1 in the same clock cycle, sequence 2 also should happen. Like here, start equal to 1, then after 2, 3, 4 or 5 clock cycle, grant should be 1, then after 2 clock cycle, request should be 0. So when request is equal to 0, at the same time it will check whether start 1 is equal to 0 or not. If start 1 is equal to 0, then it is going to check all those conditions. If this condition plus this condition from to here all are satisfied, then assertion is passed. Else assertion will be failed. Okay. So now here, what is the issue? Okay, now just let check with this sequence. Okay, so that is the problem. Let start is equal to 1. Then if after 3 to 5 clock cycle, grant is equal to 1 and request is equal to 0, then correct. Assertion is passed. But if start is equal to 0, then I don't need to check the assertion, because I don't care when start is equal to 0. But still tool is going to check whenever start is equal to 0, it is going to check what is the grant value, what is the request value, although it does not matter. So to make sure that, so in the above, like in the sequence 1, when start is equal to 0, it does not matter grant and request values. Still tool is going to check their values. That makes simulation slower. So we should, whenever start is equal to 1, at that time only grant and request signal should be checked. For this, implication operator is used. Okay, so again this implication operator, it is of 2 types. Overlapping, non-overlapping. So same condition. This is hashes 1. If I am writing hashes 1 means after 1 clock cycle. If I am writing hashes 0 means it is like from the same clock cycle. Okay, so here what can I write? So if start is equal to 1, then only it is going to check from the same clock cycle. It will start checking whether for 3, 4 or 5 clock cycle grant is equal to 1 or not, 3 or 4 or 5. If I am writing like this, so it is like if start is equal to 1, then after 3 or 4 or 5 clock cycle, grant should be equal to 1. Okay, let I am writing this. This is like non-overlapping. Okay, so just 1 minute late. Yes. So in the non-overlapping, what it will check? Start is equal to 1, then from next clock cycle it will start checking. From next clock cycle it will start checking means it will check for 4, 5, 6, because from the next clock cycle, here only has one is delayed, next clock cycle. Okay. Sorry, this is simple hashes 3 to 5. Because if it is same clock cycle, then 3, 4, 5. But here already one clock cycle is gone. So it is like 4, 5, 6 clock cycle. It is going to check. It's simple. Start 1 hashes 1, 2, 3. Start. Okay. So overlapping means here sequence is detected, it will start detecting next sequence from this clock cycle only. Non-overlapping means here one sequence is detected, then it will start detecting next sequence from this passage of clock. This is one passage of clock, this is another passage of clock. From here it will start detecting next sequence. So this is like overlapping and non-overlapping. Okay. So overlapping, this overlapping symbol is like this. From the same clock cycle, start checking. Non-overlapping symbol is like this. From the next clock cycle. So next it is okay. So now after that we have some repetition operator. Again for this repetition we use the star symbol. So many operators are associated with this assertion. I'm just explaining with a simple example. Okay, so that for example I don't have to waste time. Okay, so now let 3 to 5. Okay. Now let this part I want to repeat it for 2 times. That grant is equal to 1, after 2 clock cycle request is equal to 0, then again after 2 clock cycle request is equal to 0. Like this. Okay, so here I can write start 2. So here what will happen? Start is equal to 1. Okay, here just I'm not writing these things. Hash 2. Then after 2 clock cycle, grant equal to 1. Then after 2 clock cycle, request is equal to 0. This should be repeated 2 times. Then again after 2 clock cycle, request is equal to 0. Okay. Let I'm writing like this. Total this sequence should be repeated for 2 times. And it is the conjugative repetition. Continuously they should happen. There should be no difference between them, no time difference between them. So here start is equal to 1. Then after 2 clock cycle, then after 2 clock cycle, grant should be equal to 1. Then after 2 clock cycle, request is equal to 0. Again after 2 clock cycle, grant equal to 1. Again after 2 clock cycle, request is equal to 0. That means here to here these two things repeated for 2 times. Okay, so 2 times means they should repeat it for continuously. This is known as continuous repetition operator. So not continuous, it is like a conjugative repetition operator. Okay, so next one is non-conjugative. So repetition operator, that is conjugative. Okay, so this conjugative operator, you can add star 2 to 3. Okay, so this is true. This conjugative operator, I can give a range also. So 2 to 5 times. 2 times, 3 times, 4 times, 5 times, 2 to 5 times it should be repeated. But whatever the repetition happens, that should be continuous. Okay. And here same thing, if I'm writing let 2 to, that means the above should repeated. That means when start is equal to 1, then the RHS, the above RHS, okay, not the LHS part, okay. Whenever start is equal to 1, next things are going to be repeated. Should be repeated for 2 to end of the simulation. So any number of times, but from 2 to end of the simulation, these things should be repeated. This dollar means end of the simulation. So now this is conjugative. Next one is non-conjugative operator. Non-conjugative means same repetition will be there, but that need not to be continuous or conjugative. So non-conjugative repetition operator symbol equal to this one. Then here, okay. So after 2 clock cycle grant is equal to 1. Then after 2 clock cycle request should be 0. So after 2 clock cycle grant is equal to 1. After 2 clock cycle request is equal to 0. Then here after any number of clock cycle, sorry, request equal to 0. It should be repeated. Okay, just wait. Let me explain you the difference between this conjugative and non-conjugative. Okay, so this is the conjugative one. So here what will happen? Start becomes 1. Then in the next clock cycle, next 2 clock cycle, okay. So next grant can be anything, I don't care. Grant can be 0. First clock cycle. In the second clock cycle, grant should be 1. Okay, so start is equal to 1. First clock cycle, grant 0. Second clock cycle, grant becomes 1. Then again, let here request is equal to 1. Then in the next clock cycle, request should be 0. So again, it should be repeated. Again, it should be repeated means like this. Sorry, request should be repeated for 2 times. 1, 2 times. In the next clock cycle, again, request is equal to 0. So this is known as conjugative. So there is no any other changes between them. But if I am talking about non-conjugative, So here request can be there. So request is equal to 0. Then again here also request is equal to 0. 2 times it is repeated. So this is known as non-conjugative. They are not conjugative. Okay, so this is the difference between conjugative and non-conjugative. Means that sequence can happen anytime, so but it need not to be particularly continuous. Okay. Now let's same thing. Okay. This thing. So here again the above RHS should be repeated 2 to 5 times. No need to be continuous. Like this. Okay. This is like non-conjugative operators. Another operator is there, throughout operator. Okay. It's similar to, okay, we simply write throughout. It's similar to non-conjugative operator. But there is one difference. The difference is that last match should happen before the end of the entire sequence match. What is meant by this one? Okay, so let I'm writing let a is equal to 1. So after 1 clock on the same, I should start. Sorry, this is not throughout operator. This is go throughout. It is another. Okay, so this is like go to repetition. Sorry, go to repetition operator. So go to repetition operator. Its symbol is also like this. So don't confuse between. This is also same symbol. Okay, so it is also not for overlapping and go to repetition operator. Okay, so if I'm using like this with a variable simple, then it is like a overlapping operator. So overlapping assertion, concurrent assertion. Okay, so is equal to 1 in the same clock cycle. I will check whether b equal to 1 or not. Then it should be checked for 3 times. Then SS1C. Okay, so here this one it is like repeated 3 times. But what is this go to operator? Okay, see here first when okay, so when is equal to 1 from the same clock cycle. Assertion started evaluating RHS. So up to 3 clock cycle, B should be equal to 1. They need not to be continuous or conjugative. But when last B equal to 1, in the next clock cycle, C should be equal to 1. This is the go to operator. Okay, but if it is a non-conjugative operation, then what will happen? Let's same thing I am writing for the non-conjugative. Then from the same clock cycle, assertion started evaluation RHS up to 3 clock cycle, B is equal to 1, need not to be conjugative. After that, C can be 1 at any time. Okay, let here first A equal to 1. Okay, next B should be 1. Okay, from the same clock cycle, it will start evaluating. Let B is equal to 0. Still, it is not an issue because it need not to be continuous. Okay, first, let B is equal to 1. next b is equal to 0, b is equal to 0, b is equal to 0, next b is equal to 1. So 2 times b is equal to 1 detected. Next b is equal to 0, b is equal to 0, next b is equal to 1. So 3 times b is equal to 1 detected. So next here c is equal to 1. See, here a is equal to 1, then b1, b0, 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 b1, 2 times b1, 3 times b1. So here go to repetition, assertion failed. But consecutive repetition passed. Why? Sorry, not consecutive, non-consecutive. Because on non-consecutive times, when a is equal to 1, after 3 times b is equal to 1, then c is equal to 1. Because it is not consecutive, so I don't care, because non-consecutive repetition will be passed. But go to repetition will be failed. Why? Because when last b is equal to 1, here last b is equal to 1, so immediately c should be 1 here. So if I want to pass the go to repetition operator, so it should be like this. Immediately here c should be 1. B is equal to 1 here. The last sequence should be matched before the end of the sequence. So here go to repetition passed. Here also non-consecutive repetition also passed. Because on non-consecutive times b is equal to 1, then c is equal to 1. Non-consecutive repetition also passed. So why this go to repetition passed? Because when last b is equal to 1, the next clock cycle c is equal to 1. That means before the end of the sequence, for the end of the entire sequence match, last sequence is matched. Okay, so like you can see, wherever go to repetition is passing, definitely non-consecutive repetition will pass. But whenever non-consecutive repetition is passing, go to repetition will not pass. So this is the only difference, that whenever the last match will happen, like here my sequence ends. You can see here the sequence is finally detected. But here is the last match detected? No, because last match is equal to b is equal to 1, next clock cycle c is equal to 1. So here go to repetition will be failed. But here go to repetition will be passed. Okay. So go to repetition, conjugative operator, then non-conjugative. So just remember the difference between them. Next, AND operator. You can write at the property P @ passage of clock sequence 1 and sequence 2. So what is this AND property? This AND means let sequence 1 started. At the same time, sequence 2 detection should start. Now sequence 1 detection ended. Sequence 2 detection may or may not end same time. But whenever sequence 2 is detected, I can say assertion is passed. Now here you just see, here a equal to 1, after 2 clock cycle b should be 1. So this sequence, first sequence will be matched. So a is equal to 1, first clock cycle, second clock cycle, b is equal to 1. So here sequence 1 is detected. Again a is equal to 1, so after 1 clock cycle, 2 clock cycle, b is equal to 1. So here sequence 1 is also detected. It is detected here and it is detected here. Now come to sequence 2. So sequence 2, C is equal to 1. So C is equal to 1. Now see, whenever the sequence A is equal to 1 means from here sequence is detected, it should be started. It should check for sequence B. If C is not 1 here, then assertion is failed. Sequence C should be 1 here. Okay, when it is detection is started, at that time it should be 1 here. Okay, so that means sequence 1 and sequence 2 should start from the same point. Okay. Next, C is equal to 1, then after 1 clock cycle, D is equal to 1, after 2 clock cycle, E is equal to 1. So here sequence 2 is detected. Again, here C is equal to 1, okay. Then after 2 clock cycle, D is equal to 1. Then after, 1 clock cycle, D is equal to 1. After 2 clock cycle, E is equal to 1. See here, this sequence is detected 2 times. This sequence is also detected 2 times. But the whole sequence will pass whenever this sequence and this sequence starts from the same point. Here A is started here, but C is not started here. So here it will be not going to pass the assertion because A is started, but C is not started here. Now again A is started here. Okay, at the same time C also started. So here sequence 1 is matched, here sequence 2 is matched. So I can say at this time resultant sequence is matched. Again remember these two sequences started same time. So that's why whenever sequence A detection ended here, sequence 2 detection ended here, their end point may be different but start point is same. So if start point is same and two sequences are happening, then the end sequence will be passed. Here also two sequences are detected. See here one sequence detected, here another sequence detected. Sequence 2 detected, sequence 1 detected. But for this case, this whole sequence or resultant sequence will not pass. Why? Because they are not started from the same time. So end means sequence 1 started at the same time, sequence 2 detection should start, sequence 1 detected ended, sequence 2 detection may or may not end at the same time. Sequence 2 is detected means this end sequence, I can say end resultant sequence is detected. Or assertion is passed. Okay. If start point is not same, then it is failed. Similarly, one is AND operator, another is intersect operator. Intersect operator is same as AND operator. The difference is that end point also match. So AND operator. Next is intersect operator. So intersect operator, I can write intersect. So here what happens, sequence 1 started at the same time, sequence 2 detection should start, sequence 1 detection ended, sequence 2 detection should be end at the same time. Then sequence 2 is detected, resultant sequence is detected. So start and end point must be same. Let's take an example. Okay, so A equal to 1, then for 2 to 4 clock cycle, B should be 1. So A is equal to 1 for 2, either 2 clock cycles. So here B is equal to 1. So here one sequence is detected. Again here A is equal to 1. Here B 2 to 4 clock cycle B is equal to 1. So here also another sequence is detected. Now C is equal to 1. So I should check when these two sequences are starting. So A is equal to 1. Here C is equal to not 1. So I am not going to check the resultant sequence. Here A is equal to 1. C is equal to 1. So start point is same. So now here end is detected here. And here C is equal to 1. Next clock cycle D is equal to 1. Next 2 clock cycle E is equal to 1. D is equal to 1. After 2 clock cycle E is equal to 1. So here it is ended and here this sequence is ended. So I can say here the resultant sequence is detected. Okay, at this point here it is like 2 to 4. It may be 2 clock cycle, it may be 3 clock cycle, it may be 4 clock cycle. For 2 or 3 or 4 clock cycle, B should be 1. So here for 2 clock cycle, B is equal to 1. Okay, so this condition satisfied. And here this condition satisfied. So here the sequence is met. End point is same, start point is same. But in AND operator, although start point was same, C and A. So here, although the start point was same, C and A, but end point was not same. Here it is ending, here it is ending. Okay. So now next going to OR operator. OR operator means either sequence 1 or sequence 2. Any one is happening, the assertion will be passed or the resultant sequence will be detected. Sequence 1 started. So here, if either sequence 1 or sequence 2 is detected, then the resultant sequence is detected. Okay. Then throughout. Okay, before going to throughout, within. Okay, within means let I am writing sequence 1 within sequence 2. Within sequence 2. So here what will happen? Sequence 2 detection started. Sequence 2 detection started. Then sequence 1 detection should end before the sequence 2 detection ends. Sequence 1 detection should start and end before the sequence 2 detection ends. Within means inside it. Okay. So now see. So this is sequence 2. So this sequence should start at the same time. This sequence may start, may not start, I don't care. But when this sequence ends, in between them, this sequence should start and ends. Means sequence 1 is within sequence 2. So sequence 1 should happen between start and completion of sequence 2. Okay, I can write this. Sequence 1 should happen between start and completion of sequence 2. Okay. Then throughout operator. That means throughout the sequence that condition should be matching. THRO. So now not C throughout A has 3B. So this is another one sequence. A after 3 clock cycle, B is equal to 1. So A is equal to 1 after 3 clock cycle, B is equal to 1. So this is one sequence, this is another sequence. Like sequence started, sequence ended. So from here to here, B should be 0. Okay, so I can write. So here sequence 2 through. Okay, so sequence 2 detection started. Then sequence 1 should be passed or should be detected until sequence 2 is completed. Sequence 2 detection started. Okay, so sequence 1 should be passed until sequence 2 is completed. Just like this example. So sequence 2 is like A, after 3 clock cycle B is equal to 1. So A is equal to 1, after 3 clock cycle B is equal to 1. Started here, ended here. So from here to here, your B should be, your C should be 0. Okay, so throughout we've been already completed. That not operator means that condition should not be satisfied. That I am writing not sequence 1. So that means if sequence 1 is not detected, then assertion passed. Okay. So next we will go to, okay, this is some functions. Okay. Okay, so just 1 minute. Okay, so you can disable a assertion also. See this assertion. Okay, let in the sequential circuit, when reset is equal to active, output is equal to 0. At that time, we should not sorry, we should not check assertion, because assertion may pass, may fail. It does not matter. If you are checking assertion in this time, then there is high chance that your assertion will be failed, because all the signals will be in 0 condition, initial condition. Okay, so at that time assertion we should not check. So how can I disable it? Let I am writing property. So property P1. So at the rate passage of clock, disable if reset. So here what will happen? Disable if reset. So here when reset is equal to 1, this property or this sequence detection is disabled. When reset is equal to 0, again we'll start detecting sequence. Here I have given one example. Okay, now here you can say passage of clock disable if reset. That means if reset, then this will be disabled. Else, sorry, if reset, then this property will be disabled. If reset is equal to like 0, then it will start detecting this sequence. Whole this property will be disabled, or you can say this is sequence detection will be disabled. Okay, so next, this is disabling a property. Okay. So next, you can use if else in the assertions. Like property P1, then at the rate passage of clock, let a equal to 1. Then in the next I can check if B, then sequence 1, else sequence 2. Then end property. Here if a equal to 1, it will start detection, start detecting sequence. Then if b equal to 1, it will check for sequence 1, else it will check for sequence 2. Okay. Next, you can declare a local variable in the property. Next, you can pass arguments in the sequence like function. Let I'm writing sequence S1. Here I can pass enable start signal, then end sequence. Here you can write any sequence you want. Okay. Now if I'm talking about local variables, then property P1, here I can declare bit A, logic B, local variables. Okay, and property. Okay, so I guess almost all the things completed. Okay. So there is another last until. Okay, I have provided another PDF. Just go through that PDF and that diagram also. That PDF is also a good one. Okay, just go through it also once. If you are facing any difficulties, ask me. Okay, you should know properly. In the assertion, they will not give you a very tough task. Simple questions they will be asking. Like I will be giving you assignments also. But you should have idea about all those things. Next is until and until with. Okay, so let I'm writing property P1. This until means it is like overlapping, non-overlapping, this kind of things. Okay, so property P1, then I'm writing A after A is equal to 1, next clock cycle, B until C, or I can write B until with C. Okay, so what is this B until C means? It is like a non-overlapping. B until with C means it is overlapping. That means A is equal to 1. Then from same clock cycle, B equal to 1 until C equal to 1. Like until C is equal to 1 clock cycle before. So for the same A is equal to 1 from same clock cycle, B should be 1 at every passage of clock until 1 passage of clock before C is equal to 1. Until with means until C is equal to 1. Okay, just one diagram you can understand. So here, let A is equal to 1 detected. Next is can be 0 here. So here passage of clock. So now let here C is equal to 1. So for non-overlapping means A is equal to 1, B should be 1 up to this. C is equal to 1, so B should be 1 up to this. But if it is overlapping, B should be 1 up to this. This is non-overlapping until this is overlapping until with. Okay. So this until with, it is like okay, until with, okay, yes, it is like same repetition operator only. Okay, you are doing the repetition, but there is some simple condition, then you can use until with. This until with, it is similar to throughout. That means last sequence should be matching. This last C is equal to 1 and B is equal to 1, this sequence should be matched. Okay, so this is all about all the things. Okay, just note it down and try to like do all those things. Okay, next is some system functions, or I can say methods used for assertion. One is $rows, $fall, then $past, then $stable. Okay, so $rows means, okay, so it will check. Okay, just let me write one example. Iterate passage of clock. If A is equal to 1, then next clock cycle check $rows B. That means at the passage of clock, if A is equal to 1, in the same clock cycle, B should go from, or B should have a passage, have a rising S. Rising S means from 0 or comma Z comma X to 1, it should go like this. So $rows means you are checking for the rising edge. $fall means you are checking for the falling edge. Here $rows check for rising edge. That means it will go from 0 comma Z comma X to 1. $fell, it will check for falling edge. That means from 1 comma Z comma X to 0. Then $past means it will check for the condition past clock cycle. How? Let I am writing passage of clock A, then here I am writing $past B for 3 clock cycle, its value should be equal to 1. So it is like A is equal to 1, the same clock cycle, from the same clock cycle, past 3 clock cycle, B should be is equal to 1. Okay. Dollar stable means it will check whether the signal value is stable or not. So dollar stable B. Let I am writing dollar stable B. That means, so when A is equal to 1, from the same clock cycle, B should be stable. B should not change. Okay. Or you can write 3 to 4 clock cycle also, B should be stable. Stable means its value should not change. Okay, so returns true if the value of expression did not change from its sample value. Okay, so dollar rows. Okay, so next going to system function and task. It is $1 hot. $1 hot expression means, okay, so $1 hot, let I'm sim 1, so it will return 1 if A value is equal to 1 hot. 1 hot coding means like this 0 0 0 0 1. That means only one bit is 1. Similarly, $1 hot 0 A, it is like 1 cold. Okay, it will return 1 if A is a 1 cold value. So what is this 1 cold value? That means A should be is equal to 1 1 1 0 1 0 1 1. That means only one bit is 0. Similarly, dollar count once A, it will count number of ones in A and return it. Then dollar is known A if A is an unknown value, then it will return 1. Okay, so you count 1, so is unknown. So these are all the functions and tasks. So here there is one important question. Difference between passage of clock and $rise. Okay, so passage of clock, it is like an event. Event means either it will go from 0, Z, X to 1 or Z to 0 or X to 0. All these are known as passage. But $rows means it will return 1 if signal is going from 0, Z, X to 1. In this condition only it will return 1. Here if any event happens. Okay. So this is all about your assertions. Please go through once these assertions with examples. See, in each and every assertion, just one example is enough. Okay, but understand properly how this is happening. So here I have written some examples also. Just try to write those exams by yourself. Whatever the exams I've written here, write it by yourself and check, or directly from here also you can check how it is happening. So this is all about today class. Okay, like this okay, so there are certain things like your mode port and programming block, clocking blocks, these things are left in SV. Okay, one more thing, how this assertion get executed, like in which event region. So I will explain you what are the event regions in SV. In SV, so many event regions are added. In Verilog, we have simple active, inactive, NBA, then postponed. But here observed, reactive, and other reasons also added here. So whatever the assertion values, they will be sampled in preponed region. Now the concurrent assertions will happen in observed region, and whatever the pass fail statements you have written, $info, $those, all those things, that will be executed in the reactive region. Okay, so this is the how the assertion get executed. Okay, so now next thing I will share you in the next video whatever the things left. Okay, so I'm just going to explain you whatever the small topics left in the SV. Okay, so in the Verilog we know that there were 4 event regions. So like in SystemVerilog there are more than event regions than in Verilog. So what are those event regions? One is prepone, next is preactive, then active. This active region was in there in Verilog. There is inactive. Inactive is there, but we don't use this one. Then is pre-NBA. Then observed. This was also not there in Verilog. Observed. Next pre-observed. Okay, so here instead of pre-NBA, I'm simply adding NBA. Here there will be pre-NBA, NBA, post-NBA like this. Then observed region, post-observed region. Post-observed region, then reactive region. After reactive, there is re-inactive. Then there is postponed. Here if we go NBA, pre-NBA, post-NBA is also there. So what are the things that is going to execute it here? So in the active region, whatever were there in Verilog, same. Okay. Like your non-blocking assignment evaluation, blocking assignment, then Verilog primitives, $display, $finish, all those things. Okay. So what happens this preponed region? Preponed region, your concurrent assertion sampled, means values are sampled. It is executed only once. Now pre-active region, it is simple for PLI call, programming logic interface. Okay, then in active region, it is same as Verilog. Then in active region, this is same as Verilog. Next is pre-NBA region. Here also, sorry, pre-NBA, post-NBA, and NBA. This NBA region also same as Verilog. Now next is the observed reason. So in the observed reason, the evaluation of concurrent assertion. It is also executed only once. So next is reactive reason. Okay, so this whatever the pre-post, that is mainly for this PLI calls. Okay, so next there is reactive reason. So in the reactive reason, what happens? Your programming block gets executed. I will tell you what is this programming block. Next, whatever the pass-fail code from concurrent assertion, that also get executed. Then in the programming block, non-blocking assignment evaluation is done. This you can think like a active only, but for programming block, non-blocking evaluation, then programming block, continuous assignment, execution, then $exit. This happens here, all these things executed in the reactive reason. So in reinactive reason, whatever the has zero statement written in programming block, has zero statement in programming block get executed. Then in postpone reason, your $stop, $monitor, functional coverage, all those things, $stop, $monitor, functional coverage, all those things are done here. So main is this reactive reason. So in this reactive reason, programming block get executed. In the active reason, your module get executed. Okay, so now here what is the programming block? Okay, so in the Verilog, there were race condition between testbench and mod design, as both were written, as both were getting executed at the same time. To avoid it, program block is used. It get executed in the reactive reason. Reactive reason. The test should be written instead of module. It should be written in program block instead of module. If you're writing in module, means it is again like a race condition. Okay, so program block, it is mainly to avoid the race round condition between test bench and DB. So you can use like a module only. Whatever you are doing in module, same thing you can do with a program block also. But the difference is that module executed in active reason, program block get executed in the inactive reason. It can contain initial block, can have initial block, but not always block. You can use forever block, but not the always block. And you should not use non-blocking assignment. So non-blocking assignment, initial block but not always block. And what are the things you should not use inside here? That is module, interface and other program block. Cannot use module, interface or other program block here. Okay. So you cannot use always block, use forever. Okay, so here the question is difference between the programming block and the tester module. So this is the difference. Module can have always block, non-blocking assignment, but programming block does not have. Next, module get executed in active region and it get executed in the reactive region. So this is not non-blocking, this is blocking. Because programming block cannot have non-blocking. You should not use non-blocking in the programming block. Okay. So this is just programming block. Then there are clocking block also. So simple things. Okay, I will show you how these things are written. Okay. So next is mode port and clocking block. Let me first show you the example. If you saw the code, then you can understand. Okay, so here test. See this test I have written inside program. Okay. Here I can pass argument like we are doing in the module. Input output also you can define like that. Now next go to interface. Now see interface, it is like the bundle of signals. Okay, so now here the signal have no direction. If I want to restrict the direction, that P address should be only input, cannot be used as output. PW data should be input, cannot be used as output. So if I want to restrict their direction uses, then I have to use the mode port. Okay, so these things, whatever I have written here, input, output, these things I can write inside the clocking block, sorry, inside the mode port also, or I can write inside the clocking block. Clock I can pass as an argument to mode port. Now see in this mode port, I am passing this clocking block as an argument. So this is driver. So when I am using the driver, this address, W data, write, P select, enable should be used as output. Means they should be get data from the generator. Okay, and this should be treated as the input. That means they should get the data from the interface. When I am talking the monitor, or should be used as the input because we are sampling all the signals. So or should be used as the input. So this is simple interface code with the clocking block and mode port. So mode port, it restricts the direction of the signals declared in interface. And clocking block, it defines the skew. That means at what time the output or input signals should be sampled. Okay. So this is the example. Now see in the clocking block, here I have given input has 1, output has 1. That means what will happen? This is my clock. So all the input signal will be sampled here after hash 1 time. All the output signals should be sampled here after hash 1 time. Okay, that should be applicable to all the signals. So like this, you can use clocking block and mode ports. So there are some restrictions in the clocking block. Is used for synchronization purpose. the set of the signals that are sampled and driven by testbench. Here the skews are defined. It will be the skew. Okay. So here nothing like all these two are the important things, how to declare it. So clocking block you can declare, or if you're not interested to let you are designing a combinational circuit, so there is no need of clocking block. Here you can simply declare the mode port. So instead of clocking block you have to write mode port. Let driver, then this much. But if you are writing a sequential circuit, then instead of simple mode port, first declare clocking block, then pass that clocking block as a mode port. You can pass the signal directly through mode port, but directly through clocking block, you cannot give any signal. Like let I am passing a signal to the interface, the direction should be mode port, sorry, interface, not mode port. It should not be like interface, not it should not be like interface dot clocking block. Okay. So this is about clocking block. So clocking block, it is simply used for, just 1 minute. So clocking block, it is just used for the synchronization purpose. Okay, so at what time the output and input signal should be sampled, and your mode port, it is used for the direction of the signals. Okay, so this is programming block, clocking block, and rest 3 things are left. Okay, that is always comp block, then always flip-flop, then always latch. So in the Verilog we were using only this always block, always at the rate. If I'm writing star, then it may be a combinational circuit or it may be a latch. If I'm writing always at the rate some passage of clock, then it will be infinitive flip-flop. So here there is confusion, like when combinational circuit, when latch, when flip-flop. So just to avoid these things, whenever you are designing a combinational circuit, instead of writing always at the rate star, write always comp. This is the better version of always at the rate star. Okay, instead of it, use always comp. So what is the issue with always at the rate star? Let I'm writing always at the rate star, then here I'm calling a function that some assign. Okay, so let b is equal to my function comma c. Okay, then end block. Okay, so now here what happens, let in the my function I have another variable a comma d. So whenever a and d value changes, always block should get executed also, but it won't. It will get executed only when c changes, because you are just passing c as an argument of the function. Whenever inside the function a and d are there, but whenever a and d value changes, this does not execute. So this is the demerit. So instead of it, I can write always comp, same thing. So definitely it will generate a combinational circuit. So here it is sensitive to a comma d comma c. Okay, And next here you can write always @ a equal to 1 in another always block, always @ a equal to 0. It won't give you any error, no error. But if you are doing these things with a combinational block, it will give you error. Means it restricts. You should not use like this. It is not preferable. But still in simulation tool it won't give you error. You have to take care by yourself. But same thing here, it will give you error. That means it is an improved version. You don't have to check manually that one variable whether you have assigned it twice in 2 blocks. Okay. Similarly, instead of always @ of clock, instead of it, I can use always flip-flop. So here always count star. Simple always, I guess. Just 1 minute. Yeah. Okay. So next is always flip-flop. So always flip-flop means it will be used for the flip-flop. So here instead of you can use always flip-flop. So you can write ALWA flip-flop @ of clock. So why it is a better one? As we know, in the flip-flop you should not use blocking assignment. But if you are using blocking assignment here, it won't give you any error. But here inside it should use only non-blocking. If you are using blocking assignment means definitely it is going to give you an error. Okay, so it is a better one. Next, only one event is permitted or allowed. Here you can write 2 or 3 events, only one event is allowed, only one block. So this is the thing you should follow when you are writing a design. But in Verilog you have to check those things manually. But here if you are using this block and these blocks are synthesizable also. If you are using these things, then you don't have to check manually. Then similarly, whenever you want to design a latch, write always latch and whatever the signals, clock or a, whatever the signals, then code. So this is when you want to design a latch. Okay. Clock or anything you can always latch, then you can write the code. Okay. So this is the things if we are using instead of always block, always latch, always flip-flop and always comp. Okay. So these are the rest parts in ASV that I completed. If still some part is left, then let me know.